Hello, hi everyone. Welcome to the Student Brand. This is our Siva sir. Today we are going to discuss about light reflection and diffraction. Light reflection and diffraction. Yesterday we discussed until light reflection and diffraction topic. Today we are going to discuss about light reflection and diffraction. So related to topic we are going to discuss. So we'll see what we can discuss in this topic. So we will discuss few problems. So related to light reflection and diffraction, we are going to discuss about concepts already completed. In the previous class, I explained about concept. So now we'll do some questions and problems also. Some questions and problems. So welcome to the class. It's like interactive class. So take a pen and a book. So make a note of it, whatever we are discussing. Everybody, welcome to the class. So in the previous video, until sign conventions, I explained spherical mirrors, sign conventions, and everything I explained, right? So now related to the sign conventions and until reflection, few questions we'll discuss. So one by one, so point by point, so we'll discuss the questions and answers. So according to the notes, whatever I have written. So with the help of notes, I will, okay, so I'll go through it. So if you know the answer related to these questions, you can let me know. If you know the answer, hi sir, hi Shivani, welcome to the class. So if you know the answer, you can let me know. Few question and answers we'll discuss. Okay. So define the following terms in case of spherical mirrors. Define the following terms in case of spherical mirrors. Like a pole, center of curvature, radius of curvature, principal axis, aperture, principal focus, and focal length. So here I already said. I said I'm. Oh, sorry, Tanishka. Yeah. Oh, great, nice. Thank you so much for attending class. I thought Shivani. Okay, done. Very good. Good job. So define the following terms in the case of spherical mirrors: pole, center of curvature, radius of curvature, principal axis, aperture, and principal focus, and focal length. So these are the points. So these are the points we need to discuss. It's about okay. So first topic. And a few more questions. See, a few more questions I'll ask one by one. If you know the answer, you can let me know. If you know the answer, you can let me know. Then by that we can save the time. By that we can save the time, right? So we can save the time. So that is already explained. Define the following terms in case of spherical mirrors. But one by one I will discuss. One by one I will discuss. I'm taking here this spherical mirror. So this is a spherical mirror I'm considering. Okay, so spherical mirror, generally related to this question, spherical mirror related to this, based on this one, definitely one question will come in the board exam related to pole, center of curvature, radius of curvature, principal axis, aperture, principal focus, and focal length related to this question. So the midpoint of the mirror is called pole. Midpoint of the mirror is called pole. So after reflection, all light rays will meet at one point. Okay, so the midpoint of the mirror is called pole. So this is the pole. This is the pole. Okay, the midpoint of the mirror is called pole. So the center of the imaginary sphere in which mirror is a part, center of the imaginary sphere in which mirror is a part is called center of curvature. And the next one, radius of curvature. The distance between center of curvature to pole is called radius of curvature. And principal axis, the line joining of center of curvature and pole is called principal axis. And aperture, the diameter of the reflecting surface or width of the reflecting surface is called aperture. And principal focus, so principal focus is nothing but after reflection all light rays will meet at one point after reflection. So here after reflection all light rays will meet at one point, their image will form. Okay, so like after reflection all light rays will meet at one point, right? So that is called principal focus, or normally we can say focus. And focal length, the distance between focus to pole is called focal length. So the distance between focus to pole is called focal length, and the distance between center of curvature to pole is called radius of curvature. Right? So this is about definition and everything. Okay, so next one. So we are going to the next point. Name the mirror which can give an erect and enlarged image of an object. Here you can see, name the mirror which can give an erect and enlarged image of an object. So in where you will get erect and enlarged image, concave mirror. So concave mirror you see, so you are taking the concave mirror like this. So based on this one, they will ask many questions. So they based on the concave mirror, last case, especially last case. So if you are placing the object here, one light ray I am taking like this, passes through focus, another light ray incidenting at the pole. So this will be reflected. So the image will form here. So here virtual image. Here an erect and enlarged image of an object. So erect and enlarged image where we'll get in concave mirror if the object is placed between F and P. The image will form behind the mirror. In this case only erect and enlarged image of the object will get. Next, an erect and diminished image of an object. Erect and diminished image, in which case you'll get erect and diminished image? In convex mirror. Erect and diminished image will get. Erect and diminished image. I hope it is clear to you all. Okay. So erect and diminished image will get in convex mirror. Okay, once again, erect and enlarged image will get in a concave mirror. Erect and diminished image will get in convex mirror. See, so in convex mirror, which are the position it is in convex mirror? So where are the position? So this is the pole, focus and center of curvature. If you are placing like this, so this will be reflected back, and here also if you are taking, this will be reflected back. If you are extending this light rays, so here image will form. So here virtual image will form. So if the object is placed at infinity, image will form at focus. So in that case also the image will be diminished image. So in convex mirror only the image will be always erect and diminished. So an object, an erect and same size of the object, So erect and same size where we'll get plane mirror. Distinction between concave mirror and convex mirror. So they're asking about difference between concave and convex mirror. So here you can see, I'm taking like this, concave and convex mirror. So here you can observe. Okay, so here I'm considering concave mirror. Here convex mirror. Concave mirror and convex mirror. So first point, Point number 1, reflecting surface of concave mirror is bulged inwards. So reflecting surface will be inward. Reflecting surface is reflecting surface. Reflecting surface is inward. Reflecting surface is inward. Inward. Reflecting surface is outward. Reflecting surface. Reflecting surface is outward. Reflecting surface is outward. Outward. Okay, so bulged outward, bulged inward. So this is the first point. And coming to the second point. So here the concave mirror forms real inverted and diminished image, virtual erect and enlarged image. So real inverted and virtual erect image will form. Here also, here in the second one is convex mirror forms only virtual and diminished image. Virtual and diminished image, always virtual and diminished image. Okay, so and coming to the third one, concave mirror has real focus. So it has real focus. So whereas here, third one is concave mirror, convex mirror have virtual focus. Okay, so next one, coming to the fourth one. So concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Whereas convex mirror is known as diverging mirror. Okay, so next one, fifth one. So the focal length is negative. Focal length is negative. Here, focal length is positive. Focal length is positive. Focal length is positive. Okay, so these are the points you can observe here. Once again, so concave mirror and convex mirror. Okay, so in concave mirror, so we can observe in concave mirror. So reflecting surface is bulged inward. In convex mirror, reflecting surface is bulged outward. So reflecting surface is outward. Okay, so here concave mirror forms real and inverted, virtual erect. So whereas convex mirror forms virtual and diminished. Always virtual and diminished image will form. Here concave mirror forms real focus. Convex mirror forms virtual focus. Okay, so virtual focus means here. So if you are taking the image will form always here. The image will form always this side only. That's why virtual focus. Whereas real focus, if the image will always form in front of the mirror. So so here you can see the image. Whatever the image is forming only this side, right? Okay. So here we can see. So always here the image and object is formed in front of the mirror. That's why. So concave mirror has real focus. So concave mirror is also known as converging mirror. Whereas convex mirror is also known as diverging mirror. And the concave mirror has focal length is negative. Whereas here directly reflector light rays are meeting. That's why it is a real focus. So here you see concave mirror. So if you are taking here, so after reflection, light rays are meeting directly. Directly reflector light rays are meeting. That's why it has real focus, and focal length is negative. Whereas here, so virtual focal length. So here you can see. So object is here you can see this is the center of curvature. This is a focus. So this is a pole. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The focal length is So in the direction of incident is in the direction of incident. That's why it has focal length is positive. Whereas focal length is so forming this side only. So image is forming. So if you are taking here the distance between focus to pole is called focal length. So focal length is negative. Here focal length is positive. So very important. Make a note of it. So you can note down very important points. You can take a screenshot also fine. Okay. So these are very important points. Whatever we are discussing. Next one. So the radius of curvature of spherical mirror is 20 centimeter. What is its focal length? So next one we are going to the finding the problem. So I hope it is clear to you all. So I am rubbing the board. Just check in one. So okay, done. Okay, so here the radius of curvature of spherical mirror is 20 centimeter. So problem, okay. So problem given. So problem is the radius of curvature is 20 centimeter. Radius of curvature is 20 centimeter. R equal to 20 centimeter and find its focal length. So find its focal length. So we have to find out the focal length. We know R equal to 2F. R equal to 2F. So from this, so R equal to 20. R equal to 20. So substitute that. So 20 equal to 2 into F. So F equal to 20 by 2. So F equal to 10 centimeter. 10 centimeter. So F equal to 10 centimeter. So the radius of curvature is given 20 and focal length they asked to find out. So R equal to 2F. So 20 equal to 2F. F equal to 20 by 2. We'll get 10 centimeter, right? So next one, next problem. We are going to the next problem. Next problem is, so name a mirror that can give an erect and enlarged image of an object. Name a mirror that can give. So question is, so I'll write name a mirror. Answer is only single line only. Name a mirror that can give an erect and enlarged image. Enlarged image of an object. So very important question. So this question is very important. Many times in the exam they will ask related to this question especially, and the concave mirror, if it is related to concave mirror, so especially this concept definitely they will ask in the exam, board exam expected question, this one. Name a mirror that can give an erect and enlarged image of an object. So which mirror? Can anyone say which mirror it is? Which mirror? Concave mirror only. Concave mirror only. So if you are taking the concave mirror, okay, concave mirror, you can see concave mirror. So name a mirror that can give an erect and enlarged image of an object. So here enlarged and erect. So in concave, see, in convex mirror you can observe convex mirror always will get virtual and diminished. So this question also we can get it. So one point is object is infinity. So I am taking pole, focus and center of curvature. It passes through focus and another light is passing incident at the pole. It will be reflected. So the image will form here. So in this case, the image is always virtual erect and diminished. Compared to here, in this case, in concave mirror. So here you can see in concave mirror. So I'm taking here. So this is a pole, focus, center of curvature. So if you place the object here between focus and pole, one light ray I'm taking like this. So another light ray. So here. So many questions will come on this topic. Many question will come. Okay. So many questions will be asked on this concept. So very, very important. 3 marks question. Very, very important. 3 marks question. So make sure that you are practicing this diagram. Okay. So palmist, dentist, and even okay. So even we can able to see this question is very, very important. Make sure that you are practicing this question. So if the object is placed between F and P, if the object is placed between, name a mirror that can give an erect and enlarged image of an object. So if you are placing the object between F and P, image will form behind the mirror. Image will form behind the mirror. What type of image will form? Virtual erect and enlarged image. Virtual erect and enlarged image. Virtual erect and enlarged image. So make sure that you are practicing this one. So definitely questions will ask on this concept. So many times this question will repeat. Many times this question will repeat. Okay. So try to practice this one. Next one. Why do you prefer? So question is. So I'll write the question. So here you can see, why do you prefer? Question. Why do you prefer? Why do we prefer a convex mirror? A convex mirror as a rear view mirror. Rear view mirror in vehicles. So vehicles. So this is the question. So very, very important question. So 3 marks question is okay. So 3 marks question will come. So this question. So 3 marks expected for board exam in 3 marks. Okay, very, very important. So here, so there are many points are there. Many points are there related to this one. Many points. So what are those? Why do we prefer a convex mirror as a rear view mirror? Okay, in vehicles. So we prefer to use convex mirror as a rear view mirror because 2 reasons. Convex mirror always produce erect and diminished image. So I will take 2 positions. So I'm taking here. So convex mirror. This is a convex mirror. So one light I'm taking here. Only 2 cases are there, right? A convex mirror. So this is a pole, focus, and center of curvature. Pole, focus, and center of curvature. Here you can see. So if you are extending this light rays, those light rays will form at a focus. So virtual, erect, and diminished, highly diminished. So virtual, erect, and highly diminished. Second case, you see, so if your object is placed, so this is a pole, focus, center of curvature. Object is placed here, one light ray I am taking, so it will be reflected, another light ray inciding at the pole. So if you are extending these light rays, so image will form here. Here also virtual, erect, and diminished. So in these 2 cases you can observe. Always virtual erect. Always. So image is virtual erect and diminished. Always you can see virtual, erect, and diminished image. So because see, in this case always highly object is placed at infinity, image will form at focus. Virtual, erect, and highly diminished. In the second case, object is placed between P and infinity. So image will form between P and F. So virtual, erect, and diminished. So always image is virtual, erect, and diminished. So in this case, so that is the reason. So we will use convex mirror. Why do we prefer? Means we'll use convex mirror. So this is the use of convex mirror. And next one, a convex gives the wider field view. It enables us to view much larger view of traffic behind us than would be possible with the plane mirror. So normally you see, so one more reason is, so if you're taking the plane mirror, so the field is like this. So the region between two extreme light rays is called field view. If you are taking the concave mirror also, this the region between extreme reflected light rays. So maximum the image will be so within this region, and the image will be, if you can see the object within this region. But whereas convex mirror, you see, we can see this much. Okay, so more field view. So field view is more for concave mirror. Field view is more for concave mirror. Field view is more for convex mirror. It's a convex mirror, right? So field view is more for convex mirror. Field view. Okay, so field view is more for convex mirror. That's why we are using this mirror. So very important. These two cases are very important. Field is more field. So why I am writing is, so it will be helpful to note down. Field is more. Okay. So more. So for field is more for convex mirror. Hi. Dhanush, creative, hi. And gamer, hi. Yesterday also came. Hi everybody. So here, so in these two cases, convex mirror is very important. So that is the reason we are using convex mirror. So two cases, once again I will explain, listen carefully. So why do we prefer convex mirror as a rear view mirror in vehicles? Why do we prefer as convex mirror as a rear view mirror? First point is you can see, so image is always, see, so in these two cases you can observe, either this one and this one. So either this case and this case also, object is placed at infinity, image will form at focus. Object is placed between P and infinity, image will form between P and F. So in these two cases, you can observe virtual erect and diminish in the first case, virtual erect and diminish in this, here highly diminished, here diminished. So anyway, always image is virtual erect and diminished. First point. So first reason. The second reason is field view, related to field view. So here these 2 points there. Here in this question, there are many questions they can ask. Many questions. Only you are thinking only one question, but it is not one question. Hi, SZ Gaming. Hi. So what is your name? So if you tell your name, it is good. So with the name, we can discuss. Okay, so here there are many questions are there in this concept. First question is, so now if the object is placed in front of the concave mirror, how the image will form? What type of image will form? Draw with the Shivam, very good. Hi. So with the help of diagram, you can explain. So by using this diagram, we can explain what type of image will form. And the second case, what is the field view? Field view definition also they will ask. The region between two extreme reflected light rays. So within this region only we can able to see the object within the region. So within the region only we can able to see the object. Within this region only we can able to see. Beyond, see, for a plane mirror only this much. So concave mirror only this one. See the convex mirror, so this much field. Because so if place any object in front of the concave mirror, we can see full view of the object. We can see the full view of the object. If you place convex mirror in front of Taj Mahal also, we can see full view of Taj Mahal. So that is the reason we are using a convex mirror as a rear view mirror. Very important. So 5 marks, definitely 3 marks question, 2 marks question, and MCQ is also very important. So MCQ is also, there are many questions, sir. Only like this only they will ask, a different way also they will ask. Is the diverging mirror, which converging mirror? Actually, this is a diverging mirror. Convex mirror is a diverging mirror because whenever the light rays are incident on it, the light rays are moving away from it. Moving here, you can see in this. That's why I did the. So I drew the diagrams. I do the two image formations. So plane mirror's angle is 90. It's not about 90, so we can see if the object is there here. So you can take this board, this a plane mirror, you can see light rays are coming like this, right? So there are many different direction. Normally you are taking the plane mirror, so this is only plane mirror, right? When the light ray is incidenting on it. Obliquely means with a certain angle. With a certain angle we can say. So it's not only along the normal line, so there are many possible ways to incident light ray on the board. Sir, plane mirror angle is 90. Gamer, actually, so dude gamer, so if you tell your name, it is good, I can call on your name, that's fine. But actually plane mirror, see, how the light is incidenting on the mirror, it depends. So it's not only 90 degrees, I said. It depends on how much angle it will incident. So if it is incidenting along the, with the oblique in the sense, with a certain angle, So if the light ray incident on the Ashwin, see, if the light ray incident on the plane mirror with a certain angle, then reflect, right? So it reflect in the same medium with the same angle. That is only right. We are discussing laws of reflection, angle of incident equal to angle of reflection, angle of incident equal to angle of reflection. See, in this, so on the board there are many possibilities. Okay, na? So there are so many ways they can ask questions. So you are thinking it is small concept, but that is the reason I am writing the questions also. So you are thinking only this question. There are many possible ways to ask questions. 3 marks question, 2 marks question, 1 mark question. So expected 4 marks also sometimes. So but 3 marks, 2 marks, 1 mark also they can ask. How they will ask? So field you, I said no here. Field you 1 mark, field you 2 marks also they will ask, 1 mark also they will ask. So and one more question also. How can you identify the mirrors without touching also? That type of questions also they will ask on it. And here one more question is. So in which mirror you will get always virtual erect and diminished. In which mirror you will get always virtual erect and diminished. Where you will get convex mirror. Here you can see virtual erect highly diminished. Virtual erect and diminished. So virtual erect and diminished. So always image is virtual erect and diminished. So this is 1 mark. 1 mark for MCQs. For MCQs also this question is very, very important. So always image is virtual erect and diminished. That's why, so this mirror is used as a rear mirror. We can see fully of the topic. So behind of us. So you can see sometimes on the mirror. So if you are taking the mirror, so there is a small mirror on it. So some people on the car and bikes, if you observe, some people they will keep the small mirror on it. So in that only we can able to see full view because that's a convex mirror. Even you can see so like you can see building corners also with a red color. So there is a pole and with red color mirror is there. No, that is only convex mirror because so the person who are coming in this way, the person who are coming in this way, So in 3 ways, so they'll place like this. Whoever coming in the base, so they can observe. Who are coming on the paths. So like that. Okay, so that is about convex mirror. So many questions will come. Many questions they will ask on this concept. Many questions, many possible ways to ask a question. In the street turning, we can see that yes, red mirror. Yes, correct only. That is only Dhanush. Okay, that is only convex mirror. So we are using convex mirror. See, so the content is extraordinary content here. Okay. So one point is in convex mirror always virtual erect and diminished image. Make a note of it. So my final view is why I'm writing, why I'm telling this many times means at least if you write a running notes, so in our own way, so no need to write as it is there on the board. So in your own way, try to write all the points, sir. For spectacles, we are using lens, right? Yes. For spectacles, we are using lens, convex lens and concave lens. So in the human and colorful word, I will discuss. Next topic is human and colorful word. In that, there are so many questions, okay, related to lens. That time I will explain. So convex lens and concave lens we are using. Now you can see. So the content is very very important. Content is the key. Content is the key. If the movie is blockbuster means content is very important. That's why. So here also our board exams, if it should be a blockbuster means we should learn the content. So I am telling very 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 high weightage topic. This question I am talking about. I am talking about related to convex mirror. Only this question. There are many possible ways they will ask. And one more thing, in concave mirror last case. So related to concave mirror last case, there are many questions. If you see my live class before, so two questions continuously two questions related to concave mirror. Here a convex mirror. Okay. So I am not able to know. So I am not coming forward to rub also. It's not coming. But still we need to go forward. That's the reason I'm rubbing the board, because the content is very very important. But still, okay. So once again I will revise. So point number one is, so in convex mirror always image is virtual, erect and diminished. Second point is, so the field of convex mirror is more. Okay. So that's the reason we can use. So why do you prefer convex mirror as a radio mirror means these points, if you write, that's enough. These 2 points. Point number one, always image is virtual, erect and diminished. Second point is field is more. So that is the reason we can see the topic behind of us. Okay. So backside of us. That's enough. Okay. Done. So next one. So next question. So actually this is, so in 6 o'clock time I explain units and measurements. So those are studying grade 11 and those are writing NEET, JEE. Okay. For them. So very very important content it is. Okay, so make a note of it, note down, try to learn it. If you have any doubts, you can ask. Okay, so if you have any doubts, you can ask. Right. Then fine. Next one. Next question is, so find the focal length of convex mirror. So here they are asking to find the focal length of convex mirror. So whose radius of curvature? So question is, radius of curvature is given how much? 32 centimeter. And finding the focal length. So how much is the focal length? Normally R equal to 2f. So can we find out and tell what's the focal length? What's the answer? Who will tell first? I'll see. Next question I will explain. Extraordinary question. Who will tell the answer? So I'm waiting for the answer. Anybody? Answer is 16. Very good. Next one. Anybody? Dhanush, very good. Big round of applause. Dhanush, creative. What is your name? Dhanush only. Okay, done. So next. So yes, 16 is correct answer. 16 is the correct answer. So Dhanush, big round of applause. Dhanush, 5 star. Okay, now onwards we will tell the answer. So we'll be giving a 5 star. Not chocolate, 5 star. Okay, done. So next one. So those names will be visible on my board. So whoever sees my video, so be. So next, we wish, we wish to obtain, we wish to obtain, we wish to obtain. So very important question. An erect, an erect image of, an erect image of, an erect image of an object, an erect image of an object, an erect image of an object using, so very important question. So just check it once. So read the question, try to answer it. Using a concave mirror, using a concave mirror, using a concave mirror of focal length, concave mirror of focal length, focal length is 15 centimeter. So focal length is 15 centimeter. So here I am saying 15 centimeter, 15 centimeter. So what should be the range of, what should be the range they're asking, what should be the range of distance, range of distance, range of distance of the object, of the object from the mirror, from the mirror. So that is a question, from the mirror, that is a question. If the image is larger or smaller than the object, draw the ray diagram to show the image formation of this case. So they asked, what is the nature of the image? So nature, they asked, nature. So again, you don't need to write the question because it will be lengthy. Nature, they asked, and smaller or bigger. So image is smaller or bigger, bigger. Draw the diagram. So draw the diagram. So this is the question. So you can see, observe. So now you can observe. We wish to obtain. So virtual erect and magnified image. Very good, Dhanush. So again, Dhanush came. So we wish to obtain an erect image of an object using a concave mirror of focal length. So answer from Dhanush. Very good. What else the answer? I'll write here if possible. Maximum whoever says. So position. Next. So what is the position? Where is the position? Can you tell anyone? Where is the position? Position of the object. Okay, virtual erected, magnified, correct only. But where position? Whoever tells the answer, first answer, I'll write your name. Hi, what is your name? Play beat. What is your name? Once again. So read the question. We wish to obtain an erect image of an object. Okay, so using. We wish to obtain an erect image of an object using a concave mirror of focal length here. So focal length. So here you need to understand. So you have to underline this one. You have to underline. So what should be the range of the distance of the object? This is one question. The range of the object from the mirror. So range of the object from the mirror. So this is the question from here. Okay. So nature, smaller or bigger, and draw the diagram. Behind the mirror. Okay, object position. Dhanush, object position I'm asking. What is the object position? Anyone? Only Dhanush is active now, right now. What about remaining students? So try to answer the question, easy question only. We wish to obtain an erect image of an object. Erect image they mentioned. And so they asked virtual erect, and so smaller or bigger. Okay. So one vote between Pole and center. No, not between pole and center. Pole and focus. Between pole and focus, correct only. Okay, so one word for bigger. So bigger image, erect image. So nature is erect, virtual erect. So one word. What about remaining students? I'll add the options. Okay, can anyone tell the answer? Anybody? It's interactive class. No, simply I'm saying if you're not answering, it's the. I will tell anyway. Finally, I will tell the answer. No need to worry about it. Whether it is correct or wrong, I will tell the answer. I will explain the answer. So no need to worry about it. At least you can attempt. If you attempt, no. So you are starting thinking. So you started thinking. Then you're working on the problems like that. Between pole and focus. Okay, Dhanush, very good. Nice. Remaining students, what about remaining students? Just check once, read the question. We wish to obtain an erect image of an object using a concave mirror of focal length is 15 centimeter. What should be the range of the distance of the object? Range of the distance of the object. Okay, so still more specific way we can say. Still more specific way we can say. Okay, so I'm started answering the question. So first point is so concave mirror is correct. Anyway, they mentioned already. They mentioned no concave mirror. Concave mirror, correct. So this is the pole, focus, center of curvature. So here it is the okay. So here they mentioned the focal length is 15. So here the focal length is nothing but pole to focus. This is 15 centimeter. 15 centimeter. This is 15 centimeter, right? 15 centimeter. So it must be placed less than 15 between F and P. Like that you have to mention. So object is placed between so here they are mentioned. If the value they mention means you must use this value to answer the question. You have to use this value. So they given specific way, right? They given in the specific way. So 15 centimeter. So focal length is 15 centimeter. What is the range they mentioned? So less than 15. So less than 15 between F and P. Less than 15 between F and P. You have to place the object. We have to place the object. Or less than 15 like that you have to mention. Okay, like that. Understood? Between F and P. Anyway, focal length already mentioned. Focal length is nothing but focus to pole. The distance between focus to pole. The distance between focus and pole. Okay. So by that we can conclude that. So image is placed. Object is placed between F and P. That is less than 15. And the second one, nature is virtual erect. Virtual and erect. So especially if they mention nature means virtual erect. Only nature is nothing but virtual erect. Keep in mind. So bigger or smaller. So enlarged image. That is nothing but. So according to the question, bigger image. Enlarged or bigger. So you can mention bigger image or enlarged. In bracket enlarged. Like that you can mention. According to the question you have to mention. And draw the diagram. So this is the diagram. Right? So in this way you have to answer the question in this way. So once again, we wish to obtain an erect image of an object using a concave mirror of focal length. So focal length is 15 centimeter. What should be the range? So they mentioned, they asked about range. Range of the distance. Range of the distance means they are asking so specific point. Clearly they are asking specific point. What is that? So with the help of 15 you have to tell. So with by using a 15 centimeter, by using a focal length 15 centimeter, you have to answer. So by using a focal length, so less than 15 between F and P. Between F and P, you have to place the object. Then image will form behind the mirror. They didn't ask about position. Anyway, they didn't ask about position. So they asked about nature. Nature is nothing but virtual erect. And then asked about smaller or bigger. So here R. So bigger image. That is nothing but enlarged image. Draw the diagram. This is the diagram. Like that. Okay. So in this way you have to answer to the question. Okay. So any doubts? If you have any doubts, you can ask me. So I'll clarify. Then we'll go to the next one. Okay. So next one. Name the type of mirror used in the following situations. So name the type of mirror. So shall I rub? Okay, done. I'm rubbing. So name the type of mirror. Name the type of mirror. So first one. So question is, name the type of mirror. Name the type of mirror. Type of mirror used in the following situations. Used in the following situations. Okay. So used in the following situations. Name the type of mirror used in the following situations. Following situations. First one is headlights of a car. Headlights of a car. So second one, side or rear view mirror of a vehicle. Rear view mirror of a vehicle. Second one, solar furnace and support your answer. Okay, so support your answer. Okay, done. First you have to understand. So this is A, B, C. So what is the answer A? What is A? And what is B? What is B? And what is C? Can you tell anyone? Those who are telling, I'll write the names. Whoever answered. A is convex. Headlights of a car. No. So clearly read the question. Read the question and answer it. Read the question and answer it. Read the question and answer it. Name the type of mirror used in concave mirror headlights. Okay. So concave, no. Convex, concave. Convex, concave. C is correct. A is wrong. B is correct. Dhanush. So for your effort, Dhanush. Next. Anybody? Hey, Adarsh. So, hi. Hey, you asked about right classes. After that, you disappeared. What happened? Hi. Anyway, you can see. Anyway, you can contact this number. Still, we can work out on it. As I said, Adarsh Mishra. So, you only write. Are you there, others? Okay, done. Come to the point. So, everyone, name the type of mirror used in the following situations. Headlights of a car. Anybody can tell the answer? Dhanush. Okay, correct only, Dhanush. First one is concave. So I'm okay. So I'm locking the answers. I'm locking the answers. So first one is headlights. Headlights of a car. Headlights of a car. See, headlights of a car mean applications. Applications are very important. First one is concave mirror. First one is concave. And the second one is convex side view or rear view mirror. Convex. Convex. And third one solar furnace is concave. Concave. So I'll draw the diagram. So first one is diagram is headlights of a car. So if you are placing object is placed at focus. So this is a pole, focus and center of curvature. Object is placed here. So these light rays are coming like this and these light rays. So those are parallel to each other. Okay. These light rays will meet at infinity. These light rays will meet at infinity. So, and next one is convex mirror. So, side view mirror. Just now I explained. I gave the answer also. So, before that, I explained many times. Okay. So, I gave the reason also why we are using as a concave mirror, convex mirror. So, why we are using convex mirror as a rear view mirror. These are mirrors only. Concave mirror, convex mirror. Convex mirror, here convex mirror, here also convex mirror, here also convex, so concave mirror, concave mirror. Clear? Anybody have doubts? Concave mirror, right? So like this, see, next one solar furnace also. So here, see option C diagram. Option C diagram, you can see solar furnace light rays are coming from infinity. So and solar cookers also, solar cookers cooking the food. So light rays are coming from infinity. Light rays are coming from infinity like this. After reflection, those light rays are meeting at one point. Those light rays are meeting at one point at the focus. At the focus. So like this. So what is your doubt, Dhanush? Ask. Okay, if you have any doubts, you can ask. So I'll continue the question and answers. So you can see here I'm saying here, sir, what happens to the size of the image of an object when it is moved gradually away from convex mirror? So gradually, if you move away from it, the size will decreases. See, if you are taking the convex mirror like this, so I'm taking here. So this is the pole, focus and center of curvature. If the object is at infinity, so light rays will meet at focus. So if you are taking object near to the mirror, near to in front of the mirror, the image will form between. So next condition, convex mirror only asked. So convex mirror only, right? Convex mirror only. So focus and center of curvature. If you place, so the image will be compared to highlight image, it is bigger. As you move away from it, here it is moving towards infinity. Towards infinity means the image will be forming at image is forming at focus only, right? So image will be highly diminished. So that's why as you move away from the convex mirror, the image size decreases. As you move near to that, so the image size is compared to previous, it will increases. Any doubt? Still? See, concave mirror is different. As you move near to the concave mirror, so according to the position, the image size changes. What is the minimum distance between an object and its real image in case of concave mirror? Wow, excellent, extraordinary, marvelous, mind-blowing, amazing. So I said many times that question. So you asked that question only. Maybe you watched the previous videos of mine, I hope. Actually, the minimum distance between object and real image is 0 in concave mirror, because so if the object is placed at center of curvature, if the object is placed at center of curvature here, so I'm drawing here, so you can observe. If the object is placed at center of curvature, so the image also will form at the same point only. Okay. So if you are taking concave mirror like this, so this is the pole, focus, and the center of curvature. So if I place the object at C, image also will form at C itself. So the minimum distance between object and image in a concave mirror is 0. 0. Okay. So any doubts? Any doubts? Any doubts? Any doubts? If you have any doubts, you can ask. Otherwise, I'll go to the next one, because we need to discuss so many questions. See, I wrote so many questions for you. Okay, we can discuss. So number of questions are there, including concave, convex, spherical mirrors. In problems also, we have to do problems also. Problems also there. So these are the problems. These are the problems. You can see. These are the problems. So I wrote. Still, so many problems are there. Here, like this, like that. We do all these problems. Try to attend the class every day. So may take a pen and book and practice with me, because problems are very important. Problems comes from this chapter. If you are starting work, if you are start doing, so one day you will get confidence. Sir, what is absolute refractive index of medium? So the speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium is called absolute refractive index. That is nothing but C is nothing but 3 into 10 power 8 meter per second. V is the velocity of the medium. Still? Okay. That's enough. Still questions are there. So you can ask many questions. Those, if you have questions, you can ask. Otherwise, no problem. And this is extraordinary question. Extraordinary question. So expected for exam. So now I will explain. See. So list two possible ways in which, the question is, list two possible ways in which, sir, what is absolute refractive index medium? I already, okay, fine. Question, list two possible ways in which a concave mirror can produce a magnified image of an object, placed in front of it, state the difference, if any, between these two images. Okay. So now you can answer. Sarah, who are you? Chaitali, I saw you. Oh, no. How are you? Okay. Hi. Chaitali, you are there, right? So in one class you answered to the question and said, yeah, I remembered. Hi. How are you? I am fine. List two possible ways in which a concave mirror can produce a magnified image of an object placed in front of it. State the difference, if any, between these two images. Can anyone say? Because this, this is very, very important question. So there are possibilities of asking this question in exam. See, many questions are there. So where each and every question is like a diamond. Okay, so whenever we speak, we will tell each and every word is a diamond. Like that here, each and every question is a diamond. That much important it is. So that's why I wrote diamonds only I collected and kept in my book. Because those questions are very important that much. That's the reason I collected all the diamonds like a diamond type questions. Extraordinary questions. I am saying extraordinary question. Each and every question gives to you as like a goosebump when you are seeing the movie. So background music comes, turn 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 turn. You'll get goosebumps. Here also each and every question like a goosebump question. Okay, that much important it is. So try to answer the question. Definitely will get. Can we see here? List two possible ways in which a concave mirror can produce. I hope it is. If you like this video, please do like, share, and subscribe my channel. A concave mirror produces magnified image when it is placed in front of mirror between its pole and focus, between focus and center curvature. Case image is virtual. Once again, a concave mirror produce Telugu works. Hey, hi. Telugu works. Srinika. Correct, huh? So a concave mirror. Srinika only, right? Or some other? Okay. So a concave mirror produces a magnified image when the object is placed in front of mirror between its pole and focus. Okay, done. And with the focus and center curvature in images. Okay, very good, Chaitali. So Chaitali got. Can I write your name on the board? So for answering, Chaitali, can I? With your permission. So very good, Chaitali. Class for Chaitali. Very nice. So you didn't give me still. Okay, very nice. Okay, done. Chaitali got. Very nice. So 5 star. What else? Answer, correct answer will be giving 5 star. Very nice. And Telugu looks still. Okay, sir. Hi, sir. Something, nothing. Only okay, sir. Telugu looks. Okay, done. See here. This question is very, very important. As Chaitali said, correct answer. See, I will draw the diagram. So if you are taking first one, if you are taking concave mirror, this is a concave mirror. Concave mirror. So this is a pole, focus, center of curvature. Object is placed between F and P. One light ray I am taking like this. Another light ray. So the image will form here. So here. So first one. And coming to the second one. Second one you see is same concave mirror. So concave mirror. So here is a pole, focus, center of curvature. Object is placed between the C and F. One light ray take it, passes like this. Another light ray. So those light rays will meet behind, like this, beyond, like this image will form. So here you can see these two cases you can observe. Maybe because of less space. Thank you, sir. Sir, I'm listening your lectures, sir, with a free of cost. Can I know your name, if you don't mind? If you don't mind, can I know your name? If your name is there, we can we can call your name. No, that's why. If it is okay, you can tell. Okay, fine. So you can type and think and type. So here you can see list two possible ways. So in which a concave mirror. So here it is point is concave mirror. So here you can keep in mind. So concave mirror. So only to the we have to salute because that is very important mirror. So concave mirror, keep in mind. So can produce a magnified image of an object in front of it. Magnified image of an object placed in front of it. Two possible ways. Yes, two possible ways they mentioned. Two possible ways. Magnified image. So you read two possible ways. Concave mirror, magnified image. So you have to underline like this. So then you will get the you can get the answer in easy way. Two possible ways. Magnified concave mirror produce a magnified image. So two ways. So two times it produce magnified image. So we don't know whether it is real image or virtual image. They didn't mention whether it is real image or virtual image. But they mentioned, sir, why you so less people are? Depends. It depends. Okay. Slowly we'll get it. So two possible ways a concave mirror can produce a magnified image of an object. So two possible ways they mentioned. Two possible ways. Only two. So you can spread a word. So I'm requesting everyone. So spread a word regarding the class. Share this link to your friends and so those who are there in our school. So those who are there in our so this topic is also helpful for JEE NEET students also and ncert, those who are writing ncert students also. You can inform to them also. Even grade 11 students also I'm taking classes for them also. Inform to everyone. So spread a word regarding the classes. That is what I'm asking. That's enough. Nothing else. Only that no. So as a Gurda action you can mention. You can take it. Sir, between what is your my name is here. See, Siva sir. Here already my profile I mentioned. Here I mentioned my profile. So I completed BTech. So BTech Mechanical. My name is Siva sir. So 10 years of experience in teaching. So I already mentioned on the okay. So right now I'm from Hyderabad. Okay. Okay, done. So spread a word regarding the class. So I hope you can see the content, how the content it is there. So extraordinary content from my end I'm giving to all. So try to ask them to join and take the classes and spread a word regarding the channel, and class, especially class. So I'm working in student the brand. I am working in student the brand. CEO of the student the brand. I am the CEO of the student the brand. It's my brand. So I am only started. So like what we can say, producer, actor, director, everything. Okay, designer, modern designer, everything me only. So I am working in student the brand. We can say proudly, no. So our brand, our channel, our institution. So I am only a founder. No, really. So my institution is there. That is only student the brand. So I'm working in my institution. I had I had a great people of 5 to 10 years experience. Faculty members are there. So in my institution, okay. So those who need any subjects, not only physics, remaining subjects also like maths, social. See, remaining students, check the question. So social, English, biology. So remaining all subjects. If you want, you can contact to this number. So great faculty members are there. Nearly 5 to 10 years experience. So more than 5 years experience faculty only there. So 15 years, 20 years experience faculty also there in my team. So I am the CEO of Student the Brand. So I am working for my institution. Okay, so if anyone want classes, so physics I will teach. So Grade-10 physics completely I will take care of it. So JEE NEET students and ncert students. So I'm teaching for them also. Remaining time I'm teaching. Grade-10 completely I'm only handling. So physics subject. Remaining subjects also. Possibilities are there. Okay, remaining subject tuitions if you want, you can contact to this number 9849812804. So my request to all, so it is a sincere request from my bottom of heart to everyone. So spread a word regarding the Student the Brand channel and inform to everyone. So from my end, I am telling, so you will get extraordinary content definitely by attending the class. You won't regret. So your valuable time, definitely it is a worthy. So worthy Varma, worth like that. So it is a worthy time. So you are spending whatever hour you are spending. See, I started 9 o'clock. Still we are continuing. So 9 I will start. 9 to 10:30 maximum, 10:30 and 11 also. So the content according to the classes. So whatever hours you are spending, definitely it will be worthy. So from my end, I am telling to you all. So join to the class. So attend to the class regularly. So regularly, every day 9 o'clock classes will be there every day regularly. So if you want a remaining class subject, tuitions or classes, okay, so guidance, anything if you want, you can contact to this number 9849812804. So my request to everyone, spread a word regarding the Student the Brand channel. Okay, how I am teaching, how the content it is there, whether it is useful or not, you only tell to your friends, ask them to join to the class. So if it is worthy, so they will only stay. If not, they will only decide. So according to me, definitely they will stay. So because so we have to tell, right? We should have our word regarding our belief, what we are, how we are, what is our content, whether it is worthy or not. Okay, we should believe ourselves first. So I'm believing myself, definitely the content is truly worthy. You can join to the class, you can attend to the class, you can listen to the class. Spread a word, that's enough. Inform to your friends, ask them to join. And listen the classes. Still further, if you want also, you can contact to this number 9849812804. So further topic explanation, further guidance if you want, you can ask. I so many years over, maybe nearly 4 years. What is your name? Still you didn't tell your name. Telugu vlogs. Are you a student or a faculty? Can you tell your name? It's okay, fine. Let me complete. See, I had a great 10 years experience in teaching. So you can say. Okay. It's fine. Okay, done. So, okay. It's not about so I am very interested to teaching. I am very passionate. So if you want, so Chaitali, if you want, check my videos. So you can check the videos, how it is, how much hard work I kept. Okay. So you can understand. So definitely it is a worthy. So according to me, because I'm very, it's like a more than passion. So beyond the point. Ah, okay. You're also physics faculty. Manoj sir. Okay, thank you, sir. Thank you so much. I'm very happy. So you join and now listening class and saying definitely. So with your blessings, definitely I will do my best. Okay, then come to the point. So remaining students, just check once. List two possible ways in which a concave mirror can produce a magnified image of an object placed in front of it. State the difference, if any. So between these two images. So if the object is placed between F and P, image will form virtual erect and enlarged image. Virtual erect and enlarged image. Hemashish. Superb. Hey, hi. Hemashish. Hey, Hamish. Hamish, hi. Thank you. List two possible ways in which a concave mirror produces. I already said. So next one will go to the next point. That is, write the uses of convex and concave mirror. Write the uses of concave and convex mirror. And one more thing, write your conclusion on the study of images of distance object formed by plane mirror, concave mirror, convex mirror. So I will explain this question. I'll explain this question. I'll write the answers to this question. Just check once. Those are. So write the use of concave and convex mirror. Concave mirror. Concave mirror. Here a convex mirror. Convex mirror. So first one is used as a vehicles. Okay, this is a concave, this is convex. So convex used as radio mirrors in vehicles. First point, used as radio mirrors in vehicles. Used as radio mirror in vehicles. Radio mirrors. Radio mirrors in vehicles. Second one, used in torchlight to get parallel beam of light. Used in torchlights to get parallel beam of light. Parallel beam of light. So used in shop security mirrors. Used as a shop security. Used as a shop security mirrors. So here used to concentrate sunlight to produce heat in solar furnace. Used to concentrate concentrate, sunlight to produce heat, to produce heat in solar furnace, solar furnace. So that is second one. Coming to third one. Used in staircase mirror. Used in staircase mirror. Staircase mirror on the double decker buses. Double decker buses. And here, third one. These are used as shaving mirror to see large image of face. Dentists use this to see large image of teeth of patients. We can see shaving mirror. So because that much it won't fit here. Shaving mirror. So A and B. Dentist use. Dentist use to see the teeth of patient. Teeth of patients. Okay. Sir, for a while I am simply joined your class. Italian. Hey, hi. Thank you so much for joining. Joining is important, right? That is very good. So very nice. Sir, what a staircase. So normally used in staircase on the double decker buses. Convex mirror. Normally when you are seeing, say as I said, in front of the houses, with the red, like a red color. So there is a big mirror. How they will keep? So in olden times there is a double decker buses. So in the okay, so even in the villages, even in the cities also, there is a double decker buses. So when the people are going up to the next floor, or when they are coming down, so they should understand, right, who are coming and who are going. For that, at the corner, they will place this mirror. They will place the mirror, so they can see who are coming at the top, who are going from the bottom, like that. At the corner, if they place at the middle, so they can easily. So this way who are coming, this way are coming. Even in the, so you can see movie theaters. So in car parking, bike parking, there is a mirror. So when they are going down, like a ground, what is this? Car parking areas. So in that, exactly when going down, so there is a mirror with a red color. So there, it means stop. So stop and go. So there they will place this convex mirror to see who are coming in this way, who are going in this way. At the corner they will place. Here also same thing. Okay, very, very important. Oh, Shivani, still you are there. Very good. So hardworking. Nice. Chaitali, thank you so much for your joining the class and answering the questions. I'm very grateful. Concave mirror and convex mirror. So concave mirror, coming to the concave mirror, you can observe. So used in torchlights to get the parallel beam of light. In concave mirror, you can see. So used to get the, you can see in a Nani movie. So Iga. So there's a introduction scene like that. So they'll place on the dish on the like a noodles paper. They'll place on the dish. So he will place the torch, then a light rays will come. So exact at the center, if you place the light rays, will become parallel beam. So that is the example. So use it in torchlight to get the parallel beam of light. So object is placed at center. The object is placed at focus. So light ray is placed. So light is placed at focus. So convex mirror used as a rear view mirror. So I said that this point is very important. So very important, very important, very important. Many times this question will come. So 3 marks question, 1 mark question, so even 2 marks question. Many times this question is expected. So make sure that you are learning this point. Very highly important, most no sensitive topic this one. And coming to the next one, so use it to concentrate sunlight to produce heat in the solar furnace. So already said, related to this also question will come. And use soft security mirrors. Yes, in soft security mirror also will use. And a saving mirror. So saving mirror to see the large image of the face. And the dentist used to see the teeth of the patient. So if you place near to the, so object is placed between F and P. F and P, image will appear bigger, larger. Okay, so that case also we can see. And used in already said the corners, if you place who are coming from the top and who are going from the bottom, they can able to see. So this is about images. So points related to concave mirror and convex mirror, points related to concave mirror and convex mirror. So extraordinary points, definitely 3 marks question is expected for the board exam. Sir, always you are saying important, highly important, 3 marks, definitely all questions will come. So whatever I am saying, so those are important. From one chapter, this many questions may not come. But among these questions, one question may come. Whatever I am saying, important questions, right? Among these questions, one question may come, like a lottery system. So if you take a piece of paper, so if you drop in the jar and you pick one piece, okay, one chit, then you can understand, right? So if you are learning all these questions, if that question, like in the exam, if that question comes, if maybe this question comes, then what you'll do? So if you are if you be ready with preparation, then you can write immediately in the exam. Okay, so without any doubt. So that's why I'm saying these are very important, highly important, most important. That's enough. So I hope almost it is 10:41. So we'll see in the next class. So that's enough. Thank you for joining, everyone. Thank you for joining and listening the class. Still, if you have any doubts, any concerns related to subject, so not only physics subject, remaining every subject, math, social, biology, chemistry, Hindi, English, like any languages, if you want, okay, classes, you can contact to this number 984981280. You can contact to this number. So myself, my name is Shiva sir. So BTech Mechanical. So 10 years experience in teaching. So this is my channel and my institution. So I'm the head, whole and soul responsible, whole and soul head for the student the brand. Thank you so much. This is your Shiva sir. Thank you.